Section 6.5, number 2. I'm going to do out 3 different problems from the homework that all use the difference of squares formula. The thing you want to look for to know that you should at least try the difference of squares is if you have 2 perfect squares. And if you do have 2 perfect squares and they're being subtracted, then you can use this difference of squares formula here. A squared take away b squared factors into a plus b, a minus b. So basically you take the square root of a squared, which is a, square root of b squared, which is b, and then you add first, then subtract in the binomials. So let's do that with w squared minus 81. So square root of w squared is w, square root of 81 is 9. So we're going to feed that into the binomials, w and 9, put the square roots. And then we want them to have opposite signs. And that would be the answer. And doing a check will help you to see why you want to have the opposite signs. So let's do a check. So if I multiply it out, I get w squared minus 9w plus 9w minus 81. The middle terms cancel out. And that's why you want to have opposite signs there. If you use the same signs, you're going to get a middle term. So they cancel out, and yep, it checks out and gives us what we started with in the beginning. So that means this factoring is correct. And this will always work if you have something squared, subtract something else squared. Let's try another one. This is 6.5, number 3. So I want to factor b squared take away 1/4. And again I check. Perfect square, yes. Perfect squared, yes, because the square root of 1/4 is 1/2. The square root of b squared is b. So that means I can use a difference of perfect squares because they are being subtracted. So I do the square root, so b plus the other root, b minus the other one. And I've got my answer. So that one's all set. Next guy. 6.5, number 7. Here we've got 2 terms, and they're being subtracted, so I need to think, okay, maybe I want to use a perfect square, difference of squares here. But that's not a perfect square, neither is that. But one thing that you always want to check, no matter what, even just mentally, is there a greatest common factor? And here there is. I can take out a 3 from both of those. And if you're not sure if there's a greatest common factor, just play around with it and see if you can pull one out. So I would take the 147 and try dividing it by prime numbers, usually 2, 3, 5, 7, just see if anything works. And we'd quickly see that the 3 comes out. So I get 9a squared, take away 49 as my leftovers. Now I've got perfect squares. The square root of 9a squared is 3a. The square root of 49 is 7. So I can use difference of squares. So I bring down the 3, then I do the square root, 3a, square root of 49, 7, opposite signs. And I have my answer.